So we're going to keep studying greatest common divisor of two numbers, but first we're going to define something called the division algorithm, and that allows us to express any two numbers as in terms of their remainder, essentially. So if we have a and b and z, so a and b integers, let's just write this out formally, a, b and z, and in particular we'll take b greater than 0, okay? Just to avoid any sort of confusion. Then there exists unique numbers q and r, and q is also an integer, and then r is as well, but r satisfies another condition that we'll see in a second. So a is equal to qb plus r, and the reason we use r is because it stands for a remainder, so it's between 0 and b. So we find the greatest q such that we can have r satisfying this condition. Well, that, like we said, it's unique q. And using this division algorithm, we can perform something called the Euclidean algorithm, which helps us find the greatest common divisor between any two numbers. And essentially, the method is we use this. So to find ab, we set r0 equal a and r1 equal b, and then for I greater than or equal to 2, ri is the remainder when dividing ri minus 2 by ri minus 1. So this is some recurrence relation, but what this means sounds a little confusing, but all this means is that starting off with a and b, we perform the division algorithm. So we write a is equal to q1 b plus some remainder, but bear in mind we've called a and b r0 and r1, but that's just for the for index purposes, because it allows us to write out these relationships a little bit easier. And then once we've done this, we now following this formula, we keep finding IRs. So we're looking for R3, so we use R2 and R1. So R1 is equal to Q2 R2 plus R3, and we keep going with this until we get to a point where we get to some Rn such that there's no more remainder, such that the remainder is 0. The remainder is 0, and then we stop, and then Rn is equal to the GCD, sorry, of a and b. So let's take a nice simple example. We want to find the greatest common divisor of 91 and 39. So following this algorithm, 91 is equal to 2 times 39 plus 13. So now we write 39 in terms of 13. 39 is equal to 3 times 13. Brilliant, remainder 0. So this is a quick example, and that means that the greatest common divisor of 91 and 39 is equal to 13. It usually takes a lot longer, not a lot longer than that, a few more steps than that. But you can do this for all sorts of examples, which is very handy. Okay, so definitely keep this in your toolbox, and yeah, perhaps in the next video we'll introduce Bezout's lemma and show how we can use that and this Euclidean algorithm together. Okay, so thank you very much for watching this video. Hopefully you did find it useful, and I hope to see you